Welcome and hello. This is a video exercise in HEC HMS. And in this exercise, we are going to be dealing with the grid to point tool. In this exercise, we're going to create an area averaged time series using the grid to point tool. On the screen here, I have the instructions. I will leave a link to this webpage in the description of the video if you'd like to follow along. Creating an area average time series here. The first thing we need to do is download the files. And before I do that, let's just go ahead and navigate to show you where I am. This is the HMS Tutorials and Guides webpage. And if you expand or widen out your browser window far enough, then you get this menu over on the left side. Where I'm located is in the Tutorials and Guides under Working with Gridded Boundary Conditions Data. And then underneath that, it's workflows for downloading, importing, and manipulating gridded data. There's a part 1 that was importing gridded data that was covered in the previous lesson, our exercise number 30. And then this is part of part 2. So we're going to be dealing with part 2A in this exercise, in this video. Like I was saying, if you scroll down here, let's start by downloading these project files. So click on Download Project File, and then click on Download. Okay, that's downloading on my desktop. So I'll go ahead and click to open up that file. Here we have a HMS file right here. So I'll just go up one level. And then I'm going to move that into a spot on my computer that I want to save it. Okay, so that's saved. I can close that window and delete the zip file. The second file you need to download is this one right here. It's a clipping file. It's just the shape file. So let that download. And then for some reason, it's opening up another tab. So go back to the first tab you were on. And then the last file we want to download is this DSS file. Okay, so that's downloaded and done. Now that we have the project on our computer where we want it, I'm going to go ahead and move the shape file used for clipping and the DSS file for our data where I want to within the HMS project directory. So the shape file is going to go into the GIS folder, which is right here. So here is the shape file. I'm going to just keep it in that folder and then move it over. Okay, so I can delete that. And then the DSS file, I'll put that in the data directory. So here's data. We already have a few DSS files in here. That's fine. Next, I'm going to open up that HMS project in HMS. I'll click open and then browse to that directory. Okay, here's the project right here. And here's the .hms file. So I'll select that and then click convert project. So if you get this message about a missing file reference, I've already looked into this and this file reference is not used. So I'm just going to go ahead and ignore it and click the close button. All right, I'm going to open up the basin map here and click on the Upper Truckee River. Here is our watershed. It has a single basin and looks like we have too many layers toggled on here. So I'm going to go to View, Map Layers, and then just uncheck some of these layers to turn them off. What we're going to be dealing with in this exercise is the grid to point tool, which is going to convert a grid of scalar values such as snow water equivalent over a number of time series, a number of consecutive grids, to a time series data, which is the average of the values in that grid inside the specified shape, which is the shape file. So that activity will take place in the tools, data, and then grid to point utility right here. In the grid to point, we'll be taking a gridded data set, applying a shape file to identify the area of that grid that we want to average. And then this tool right here will calculate the average value of that grid for each time interval and output a time series data set. So our first step here is to select the source file as it says right at the top. So I'll go ahead and navigate to that DSS file that we downloaded and put in our data directory. Here's my project file. Here's the data directory. And then here, this at the bottom here, it's my SWE, snow water equivalent grid. Okay. Before we do the conversion, it might be good to actually see the values. So let me open up DSS view. And then I'm going to navigate to that data directory again. All right, here's my project. Here's the data directory. And here is the grid representing snow water equivalent. What we have here is data for one grid per day. It looks like it starts on October 1st and it goes for the entire water year through September of the next year. So 12 months of daily data. So 365 records. Yep, right there. All right, I'm going to select all the records and then just click open. What we see here is a graphical display of that grid data. So if I click ahead, I'll see some different colors appear. This represents the snow water equivalent for this area, where I believe green is 0. Yep. And then non-green is a non-zero number. So let me just click ahead a little further. We are just starting December, December 15th. Now we're into January. As you can see, we have snow accumulation in this area. If I click on grid info, it's telling me this is in millimeters and gives me some other information, some metadata about coordinates and so on. But if we just click over the grid, this value right here is 317 millimeters. So that would be 30 centimeters, about 1 foot. And then if I go to like a green cell right here, this is only 10 millimeters. So anyway, if I happen to have a shapefile that drew a little circle in this area, then the grid to point tool would create an average of the values inside that shapefile. So for instance, it might be like 100 or 200. All right, so that's what's happening there. Let's go back to our tool. Here it is. And what we're going to do is select all the grids, so all 365. Just Control A will select them all. I'll click the arrow over tool, the greater than symbol in this button, and then click Next. Okay, now we need to apply the shape file. This was the other file we downloaded and put in the GIS directory. Okay, so here's the project. Here is my GIS directory, and then my shape file should be in here. There it is, and open. Okay, so it is selected. You just can't see it. It's kind of cut off there. Click Next. Now we need to specify the output destination. This is going to be the location of our DSS file. I'm going to navigate to the data directory once again. Here's my project. Here's the data directory. And then I'm going to call this snow water equivalent underscore AVE for average.dss. Okay. For my path name parts, I'll go with SHG. And the instructions tell me to type in Upper Truckee River for part B, but it looks like I'm kind of blocked off from that. But for part F, I'm going to type in average snow water equivalent. Okay. And next. All right. So grid to point has been complete. I'll close that. Let's go ahead and take a look at that data. I'm going to use DSS View again, just because it's convenient. Here is that new DSS record. And then if I click Open, we have a single time series data set. And then here is the plot right here. This is pretty much what I expected to see. Don't get thrown off by the vertical units because it converted to inches. So instead of hundreds of millimeters, we have inches that go up to about 4 feet, almost 48 inches. And we have no snow during the summer months and then quite a bit of snow during the winter. So that's typical of the Tahoe, Truckee area. Next thing in the tutorials, we're told to add a time series data set to our HMS model. So I'm going to go ahead and go back to HMS. In the components menu, I'll click on time series data manager. And what I want to select for a type is going to be snow water equivalent gauges. Looks like we already have a couple here. So we're going to use one of these to compare with later. I'll click on new. I'll give it a name. And then I'll also give it a description and then click create. Okay, so I can close the manager. I'm going to go to my time series data directory here in the Watershed Explorer, expand my snow water equivalent gauges, and then click on the gauge I just created. Now, a couple things need to happen here. First, I need to select that DSS file. So instead of manual entry, I'll click single DSS file. Again, here's my project. Here's the data directory. Here is the time series data set is in this DSS file. And then I should have just one record here. There it is. Set path name. That's good. So if I click save there, that's good. I'm also told I need to update the time window. Yeah, so if I expand the time windows here, I'm seeing just the default range. And this needs to be changed to the actual values, which is October 1st from noon until August 15th here. This is also at noon. I'm going to click save to that. The next step tells us to create a new basin. So what we're going to do here is just to take the existing basin up here in the Watershed Explorer, right click, create a copy, and then you can type in a name or paste in a new name. This will be for that University of Arizona snow water equivalent basin. I'm going to expand the basin, click on our subbasin element, and then down here in the components editor, here's subbasin tab. There's this options tab right here. I want to change the observed snow water equivalent from the existing value here that we copied from to the time series data set that we created using our grid to point tool. Next, what I want to do is create a simulation that uses this new basin, which has our new observed data, and then I can compare the two observed time series data sets together after running the simulation. So let's go to Compute, Simulation Run Manager. There's already a couple simulation runs already. We're going to actually compare with RTMA, but I'll click New here, and then we'll give it a name for our new simulation run, and then click Next. Then the basin we're going to use is this one right here, no water equivalent. The meteorologic model was going to be water year 2017, and then the control specification will be the full year, water year 2017, and finish. Okay, save that. Now we can run the two different simulation runs that we need to. First, the one that we just created. Okay, that finished up. Now let's run the RTMA model. Okay, that finished up. Let's go ahead and check out the results. I'm going to click on the Results tab here in the Watershed Explorer, expand the simulation run. Now we have two different runs that we've already completed and have results for. So I'm going to expand my sub-basin element in both results right there. And what I want to select is the observed snow water equivalent value. So it's going to be, there it is, observed snow water equivalent. And then in the other model, it's right here, observed snow water equivalent. I'm holding down Control at the same time as the click so that I can capture multiple time series in the same preview plot down here. I'm going to go ahead and just click the graph button up here. And now we have our two data sets that are pretty much on top of each other, except for a few months towards the end of the water year. Okay, I've changed the plot coloring to red and blue, so hopefully this makes it a little easier to see. In red here, we have the original RTMA results, and then blue here is the observed snow water equivalent data that we just created. And what this tutorial ends with is the comment that the similarity between these two data sources provides a quality check on the gridded data. So what we did here in this exercise was we took a snow water equivalent gridded data set for an entire water year. Then we applied a shapefile to mask out just the area we wanted. Then using all those inputs, we created a time series data set of average values for those snow water equivalents that we're seeing on the screen in the plot here.